Good evening, astronauts. For countless generations, humanity has gazed in awe at the boundless night sky, nurturing the belief that it held the key to understanding its slow, majestic cosmic dance. With unwavering persistence, we meticulously mapped the paths of wandering planets, charting their unhurried movement across the celestial dome. We carefully charted the luminous, ghostly clouds of nebulae that appeared as cosmic works of art. Ultimately, our gaze turned to the swirling, mesmerizing grandeur of distant galaxies, each a colossal, self-contained island of stars, an entire universe in miniature. We were confident that we had grasped the story of creation, the gradual, measured unfolding of the cosmic tapestry, the hesitant dawn of light piercing through primordial darkness. We firmly believed that the universe assembled itself leisurely, brick by brick, over unimaginable, dizzying stretches of time. Yet, then a completely new eye opened upon this apparent void. An eye crafted from gold, embodying impossible ambitions, was launched into the silent cosmic darkness a million miles from Earth. This was the James Webb Space Telescope. It was designed not merely to peer further than ever before. It was engineered as a true time machine, capable of piercing through 13.5 billion years of cosmic history, reaching the very infancy of the universe. And what it discovered there was not the quiet, primordial cradle we expected to see. It found an anomaly so profound, so utterly unsettling, that it threatens to shatter our most fundamental understanding of existence itself. Imagine looking into the very dawn of time, an era where we believed only scattered cosmic dust and the faint whisper of hydrogen should exist. Now imagine that in this impenetrable darkness, you clearly see a fully formed megalopolis, a colossal city of billions of stars, already ancient and blazing with dazzling, furious intensity. And it's not just one such galaxy, but an entire population of these formations. Monstrous galaxies, incredibly mature, already ablaze with light at a time when the universe was less than 3% of its current age. This was the forbidden image sent back by the James Webb Space Telescope. It is irrefutable evidence of a universe that built itself with terrifying speed. This should not be possible, according to our current understanding. It is the story of a universe far more turbulent, far more ancient and mysterious than we ever dared to imagine. It is a cosmic horror story, where the monster is a destructive truth, and the crime scene is the very beginning of time. We stand on the precipice of unraveling the forbidden secret of the universe's impossible galaxies. A secret that may rewrite the very laws of physics. And if you have ever looked at the stars and felt that primal mix of awe and a deep, unsettling dread, then this story will resonate with you profoundly. For decades, our cosmic story was crystal clear. It was a tale of boundless patience. A story of gravity's slow, deliberate craftsmanship, sculpted on the grandest of all possible timescales. We called it the Lambda Cold Dark Matter Model, or Lambda CDM. It wasn't just a theory, it was the cornerstone of modern cosmology. A grand unifying symphony that, with unnerving precision, explained the universe we saw around us. This model painted a picture of majestic hierarchical growth. A universe that built itself from the bottom up. Imagine the moments after the Big Bang's tumultuous, blinding crescendo had subsided. The universe, then, was a formless fog of hot, ionized gas. No stars, no galaxies, no planets, just impenetrable darkness pregnant with boundless possibility and cosmic-scale silence. The only structure arose from tiny, almost imperceptible fluctuations in density. Ripples in the primordial soup left over from the very first instant of creation. The cosmic microwave background, that faint, ancient afterglow of the universe's dawn, was a kind of blueprint, and according to our story, that blueprint demanded slow, painstaking construction. The unseen architect of this grand construction was dark matter. This mysterious, ghostly substance that doesn't glow, doesn't reflect light, and interacts with it in no way. It is the cosmic scaffolding, 5 times more massive than all the familiar matter of stars and gas. We believed this cold dark matter began to clump first, its immense gravity acting as a silent, irresistible beckoning. These were the seeds, the gathering points in the vast, empty dark. We thought these dark matter halos acted like cosmic spiderwebs, slowly, patiently ensnaring the wisps of hydrogen and helium drifting in the void. So there was a known rule, deeply ingrained in our understanding of the cosmos. We were convinced that galaxies originated as modest, barely discernible clumps, mere tiny fragments of light and gas, slowly coalescing under relentless gravitational influence. Imagine the process of a river delta forming. Countless minuscule streams, each seemingly insignificant on its own, gradually merge, carving their paths and combining into currents. These currents, in turn, join to form mighty rivers that ultimately flow into the boundless sea. Our own Milky Way, we presumed, was the result of this grand cosmic river system, built over 13 billion years by continuously absorbing hundreds, perhaps thousands, of smaller dwarf galaxies. We believed in a slow universe, a patient universe, one that assembled itself with the meticulous care of a master watchmaker. To use another analogy, imagine the construction of a colossal skyscraper, a building so vast it pierces the clouds. The Lambda CDM model asserted that this skyscraper was not built from massive prefabricated sections dropped into place overnight. No, it was erected brick by tiny brick, each brick a small cluster of stars, each brick a pocket of gas, and each one was set into place by the slow, painstaking mechanism of gravity over billions of years. This was the fundamental bedrock of our understanding, a story we were unshakably confident in its truth. And so, we built an instrument, an eye, to observe this story unfold. A golden eye made of 18 hexagonal mirrors, chilled to a few degrees above absolute zero. This instrument of impossible ambition was launched 1 million miles from Earth to peer into the abyss of time itself. This is the James Webb Space Telescope. Its mission was to witness the universe's first moments, to see those first, faint, flickering embers of the cosmic dawn. It was built to find the tiny bricks, the cosmic saplings, the gentle whispers of light that our grand theory predicted. However, the James Webb Space Telescope broke that rule. It shattered it with one devastating observation that sent shockwaves throughout the field of astrophysics. It looked back to an era just a few 100 million years after the Big Bang. This was a period we call the Cosmic Dawn, an era that should have been cosmically empty, a dark age populated only by the most fragile embryonic structures. We expected to find the celestial equivalent of fireflies in a vast, dark forest. Instead, it found roaring behemoths. The first images that came back were not faint, diffuse proto-galaxies. They were massive, luminous, incredibly well-formed galaxies, looking shockingly mature, blazing with the light of billions of stars. These were colossal star cities, already ancient and established at an epoch when only cosmic villages should have existed. It was like planting an acorn in the ground, turning away for a minute, and then looking back to find a 1,000-year-old oak tree, its mighty branches already sprawling across the sky. This should not have been possible. The light from these monstrous objects had traveled over 13.4 billion years to reach Webb's golden mirror. We were seeing them as they were when the universe was less than 3% of its current age. Only 300 to 400 million years had passed since the tumultuous singularity of creation. On the scale of a human life, this is the equivalent of the first few months in a mother's womb. And yet, here were fully formed entities, galactic titans that, according to our models, should have required 10 billion years of slow, steady mergers to assemble. The data was a direct, jarring contradiction to the majestic hierarchical growth we held as truth. NASA and European Space Agency scientists were stunned. The initial reaction was disbelief, a suggestion of instrument error, a miscalculation in analysis. They checked the data again and again. The signal was unambiguous. The terrifying anomaly was real. There, blazing in the infant universe, were galaxies as massive as our Milky Way is today. One such object, Glass Z13, was a dazzling beacon, a fully formed galaxy seen just 330 million years after the Big Bang. This was not a tiny brick. This was a finished skyscraper, lights on in every window, standing proudly in what should have been an empty construction site. The cosmos, it seemed, was not at all what astronomers imagined. And then, things became even more dramatic. The initial shock was deeply felt. For months, as the James Webb Space Telescope gradually cooled to its operational temperature 1,000,000 miles from our planet Earth, the global astronomical community was in a state of tense anticipation. They knew precisely what they were about to discover. Decades of painstaking simulations, run on our planet's most powerful supercomputers, had painted a clear and consistent picture of the cosmic dawn. The universe, in its infancy, was supposed to be a place of fragile beginnings, a quiet cradle shrouded in cold darkness after the fading afterglow of the Big Bang. The theory possessed an astonishing elegance, telling a story of a patient, hierarchical formation process. It began with silent darkness, a vast, ever-expanding void filled with little more than hydrogen and helium, the raw elements forged in the first 3 minutes of creation. Within this primordial soup, the tiniest quantum fluctuations, magnified by cosmic inflation, gave rise to regions of slightly higher density. These were the seeds, a kind of primal cosmic soil. Gravity, the tireless sculptor of the universe, then began its slow, methodical work. Over hundreds of millions of years, it gently pulled these gaseous tendrils together, gathering them into diffuse, chaotic clouds. From these clouds, it was hypothesized, the very first lights would ignite. Stars. Not entire galaxies, but individual, solitary points of light. These stars were dubbed population 3 stars. They were described as theoretical monsters, composed solely of pure hydrogen and helium. They were hundreds of times more massive than our Sun, and burned with a dazzling blue-white intensity for a few short, tumultuous million years before exploding in cataclysmic supernovae. These were merely the first sparks, tentative embers in a colossal cold fireplace. And only after countless generations of these solitary titans had lived and died, seeding the void with the first heavy elements, could true construction begin. These enriched gas clouds would then, even more slowly, begin to collapse, forming the first true proto-galaxies. Astronomers using the Webb telescope expected to see precisely these structures. They were looking for the cosmic equivalent of saplings pushing through primordial soil. Faint, small, amorphous clumps of matter, barely glowing, containing perhaps no more than a few million stars. They were hunting for cosmic ghosts, faint smudges of infrared light that had traveled over 13 billion years to reach Webb's golden mirror. They were ready for the challenge, to tease the signal from the noise, to find the faintest whisper of creation at the edge of time. But this was not what they found. What they found instead proved far more unsettling. The first images, part of the JWST Advanced Deep Extragalactic Survey Program, were not whispers. They were a primordial scream from the dawn of time. Where there should have been faint, fragile structures, Webb provided images of fully formed ancient giants, sprawling stellar megalopolises already blazing with mature, furious light. These were not saplings. These were ancient redwoods in a field where only scattered seeds were expected to lie. The data, streaming in from the Lagrangian point, was processed at the Space Telescope Science Institute and bloomed on screens as something utterly impossible. A stunned silence descended upon conference rooms. Researchers double-checked the numbers again and again. The data was impeccable. The observations were unambiguous. The universe, it seemed, was lying about its age. We believed that galaxy formation was a slow process, taking billions of years to build the majestic spirals and massive ellipticals we see in our cosmic neighborhood. We thought the early universe was a cosmic desert, sparsely populated by the first tentative sparks of structure. We thought we understood the timeline of creation, the majestic gradual unfolding from simplicity to complexity. This was the bedrock of modern cosmology, the grand narrative of our cosmic origins. Yet, just 280 to 500 million years after the universe's tumultuous birth, these monstrous galaxies stood defiantly.
To put that timescale into human perspective, imagine the entire 13.8 billion-year history of the universe compressed into a single 80-year human lifetime. The period Webb observed would be equivalent to the first 5 months of infancy. Our models predicted that at this stage, the universe would just be learning to form its first cells, its first stars. What Webb found was the cosmic equivalent of a fully grown, thinking, speaking human in a cradle. It was a biological, physical, cosmological impossibility. This should not have been possible. The anomaly in question was by no means a singular, isolated finding that could be easily dismissed as a statistical fluke. On the contrary, early data from the Cosmic Evolution Survey, CES, another deep cosmic survey, began to steadily corroborate these astonishing discoveries. The James Webb Space Telescope had found not 1, not 10, but over 100 relatively bright and massive galaxies in this extremely early epoch of the universe. This number significantly exceeded the wildest predictions and expectations of scientists. One early, now widely cited study identified a sample of 6 candidate galaxies, each estimated to weigh over 10 billion solar masses. One, in particular, appeared to contain a colossal mass of 100 billion suns. The existence of a galaxy of this scale, formed just 500 to 700 million years after the Big Bang, is in direct defiance of the standard lambda-CDM model. Within this model, there simply isn't enough time for it to have formed. The laws of physics, as we understood them, stated that it was impossible to gather such an enormous amount of matter, condense it, and ignite billions of stars in such a short time frame. It's comparable to finding a photograph dated to 10,000 BCE depicting a fully constructed Great Pyramid of Giza. The necessary materials weren't available, the technology was absent, and the time itself was unsuitable for such a grand construction. Thus, these weren't just isolated anomalies. This was an entire population of impossible structures, a kind of forbidden census from a long-lost era. Every tiny point of light in these deep cosmic images transformed into a source of profound intellectual dread. Each represented a devastating contradiction to existing scientific understanding. The light from these galaxies began its journey to us when the universe was less than 4% of its current age. And yet, many of them looked shockingly normal, possessing evolved structures, high luminosities, and implied stellar masses that we calculated should have taken billions of additional years to form. It was as if the universe had a secret, accelerated history it had kept hidden from us until now. One of these cosmic giants, dubbed Glass Z12, was confirmed as being observed just 350 million years after the Big Bang. This was not a faint, barely perceptible smudge. It was an already substantial, organized system, burning with furious intensity. To form the sheer number of stars required to shine so brightly in such a short time frame, the galaxy would have had to convert available gas into stars with an efficiency bordering on the physically absurd. It would have had to be a stellar factory of monstrous, impossible speed, with no downtime, no waste, and no regard for the physical limits our models had so painstakingly established. These galaxies were too big, too bright, and too early. The very concept of early was beginning to crumble relentlessly. What did it mean for the universe to be young if it was already populated by such colossal, mature structures? This was a cosmic anomaly of such magnitude that it threatened to redefine the very timeline of existence. We aimed our greatest technological eye at the very beginning of history, expecting to read the first simple sentence. Instead, we found the final chapter already written, bound in ancient leather and glowing with a terrifying light. And then, the situation became even more unsettling. The problem wasn't just their size or their brightness. The problem was what their very existence implied for the invisible architecture that holds the entire cosmos together. The implications of these premature cosmic titans reached far beyond mere time.
They struck at the very heart of our understanding of gravity and the unseen architecture of the universe itself. For half a century, our cosmology has rested on a colossal, yet invisible foundation. This is a substance that makes up over 85% of all matter in the cosmos. We call it dark matter. The Standard Model, our grand narrative of cosmic creation, known as lambda-cold dark matter, posits that this unseen substance is the silent protagonist of the universe's story. It is the great assembler, the cosmic shepherd. In this model, dark matter is cold, meaning its particles are heavy and slow-moving, interacting with the universe almost exclusively through the gentle, persistent pull of gravity. Imagine it not as a substance, but rather as a vast, unseen web stretched across the boundless reaches of space. After the grand event known as the Big Bang, this cosmic web set about its patient contraction, its invisible threads slowly drawing in the primordial hydrogen and helium like a giant gravitational tide. This process, it was understood, had to be majestic and unfold gradually. For a long time, galaxy formation was thought to resemble the leisurely growth of a crystal in a supersaturated solution, with dark matter acting as the initial seed. We believed it akin to the painstaking construction of a magnificent cathedral, stone upon heavy stone, erected over centuries of diligent labor. Billions of years, then, seemed the necessary timescale for this grand process. According to these ideas, dark matter would first have to form colossal, invisible halos, gravitational wells spanning tens of thousands of light-years. Only after these gargantuan, unseen scaffolds were fully formed could ordinary matter fall into their gravitational embrace, ignite into stars, and coalesce into the spiral cities of light we now call galaxies. This was the unbreakable rule, the cosmic law. However, the rapid, almost instantaneous emergence of colossal galaxies in such early stages of the universe's history seemed to completely contradict the slow gravitational pull that dark matter was, by all accounts, supposed to provide. The James Webb Space Telescope revealed a monstrous reality. It turned out the cathedrals were already fully built, blazing with dazzling light, but their foundations had never been laid. The scaffolding was non-existent. The timeline of construction, a process that should have taken billions of years, was compressed into a tumultuous, utterly impossible instant. This simply should not have been possible. The discrepancy between prediction and observation was far from subtle. It was a stark, devastating contradiction. The Lambda CDM model makes very specific predictions about how many massive galaxies should exist at any given epoch. In the universe's infancy, just 300 to 500 million years after its birth, that number should have been effectively zero. The slow, cold nature of dark matter simply doesn't allow for enough material to be gathered so quickly. It's a fundamental speed limit built into the theory. However, the Webb data screamed otherwise. It demonstrated not one, but an entire population of these impossible structures. These galaxies possess stellar masses reaching 1 billion. Astrophysicists repeatedly ran simulations, desperately trying to force the Standard Model to accommodate this terrifying new data. They tried to accelerate the clumping of dark matter. They tried to make gas cooling more efficient, but the models consistently failed. For these galaxies to be built in the allotted time, dark matter would have had to behave not as a cold, slow-moving substance, but as something far more aggressive, far more efficient. It would have had to act as a gravitational catalyst of monstrous and utterly unprecedented power. The numbers simply did not add up. And then, things only got worse. The data wasn't just a challenge, it was an outright indictment. Stacy McGaugh, an astrophysicist at Case Western Reserve University and a longtime researcher into this cosmic mystery, articulated the problem with chilling clarity. What the dark matter theory predicted does not match what we see. This wasn't the polite language of academic debate. This was the sound of a paradigm cracking under unbearable pressure. It was a crushing revelation, an admission that the ghost in our machine, the invisible matter we had invoked to explain the universe, was now itself the source of our deepest confusion. For decades, scientists had sought a specific particle, a WIMP or an axion, to play the role of dark matter. Now, they were faced with a far more disturbing possibility. The role itself was miscast, the entire script fundamentally flawed. Suddenly, a once marginal concept, a theory relegated to the shadows of cosmology, began to resurface. It was an idea many considered a form of scientific heresy, a forbidden alternative to the dark matter dogma. It is called MOND, or Modified Newtonian Dynamics. First proposed in the early 1980s by Israeli physicist Mordechai Milgram, MOND offers a profoundly different and deeply unsettling vision of the cosmos. It suggests that dark matter does not exist at all, not a single particle. The missing mass, the strange gravitational effects we observe in galaxies, are not explained by some invisible substance. Instead, MOND asserts that our understanding of gravity itself is incomplete. The theory known as MOND, or Modified Newtonian Dynamics, is both striking in its elegance and terrifying in its implications. It posits that at familiar cosmic scales, such as planetary systems, star clusters, and entire solar systems, the classical laws of gravity formulated by Newton and Einstein remain impeccably accurate and applicable. However, when it comes to regions of extremely low acceleration, such as the vast, virtually empty expanses on the outskirts of galaxies, gravity, according to this theory, begins to behave in an entirely different manner, deviating from our expectations. It does not weaken at the usual rate. Instead, its influence becomes stronger, more powerful, and its attractive grip extends over much greater distances than our current laws of physics predict. The essence of this idea is not that more matter is pulling objects together, but that the pull itself fundamentally changes its nature. Imagine a flame burning in our familiar Earth atmosphere. Its behavior remains predictable. But transport that same flame to a different, utterly alien atmosphere, and it might suddenly flare 1,000 times brighter, emitting 1,000 times more heat. Its fundamental properties would change under the influence of its environment. MOND suggests that gravity undergoes a similar transformation when it finds itself in the near-absolute vacuum of intergalactic space. For decades, MOND remained something of a wild theory, compelling in its ability to explain galaxy rotation without the need for dark matter, but lacking the broad explanatory power of the standard lambda-CDM cosmological model. However, the unsettling discoveries made by the James Webb Space Telescope have given this theory unexpected and powerful corroboration. If gravity was indeed intrinsically stronger in the low-density environment of the early universe, it could provide a mechanism for monstrously efficient and incredibly rapid galaxy formation. In such a scenario, the pre-existing dark matter scaffolding would not be required. Primordial gas could pull itself together with its own enhanced gravity, rapidly collapsing into stars and forming colossal structures at a rate that seems utterly impossible under the old rules. Thus, the impossible galaxies discovered by Webb ceased to be an anomaly. They became a prediction. MOND transformed them from a cosmic problem into corroborating evidence. And so, the scientific community is now forced to confront a forbidden question, a choice between two cosmic horrors. Which is more likely, that 85% of the matter in the universe is an invisible, untouchable substance that behaves in ways that directly contradict our best models? A cosmic ghost whose presence we infer, but whose actions now contradict the very reason we invented it? Or is it more likely that our understanding of the most fundamental force in nature, the very law that holds our world together, is wrong? That gravity, the first constant we ever truly measured, is not a constant at all? This is the abyss we now stand at the edge of, and we must ask ourselves, what if we have been fundamentally wrong about the most prevalent form of matter in the universe? Or perhaps the far more unsettling question, what if we have been wrong about the very fabric of space-time? The James Webb Telescope was built to detect the first light, but instead it discovered a profound philosophical darkness. This is a crushing choice, one that may forever redefine our place in the cosmos. The mystery was not a whisper. It was a scream from the edge of time. With each new observation, each distant flicker of impossible light gathered by its golden mirror, the James Webb Space Telescope deepened the cosmic wound it had opened. The initial shock of finding early galaxies was now giving way to a deeper, more structured horror. Patterns were emerging from the chaos, and they were terrifying. Among the anomalies, one stood out particularly. A singular, dazzling entity from an era that, by all accounts, should have known only darkness. Its official designation is JADES GS-Z14-0, a cold, clinical name for a cosmic monster. But the astronomers on the JWST Advanced Deep Extragalactic Survey, the JADES team, simply called her Moms 14. A seemingly innocuous nickname, but one that hinted at her colossal, matriarchal status in the infant universe. She was observed as she existed just 280 million years after the Big Bang. Let us pause and comprehend that number. 280 million years. If the entire 13.8 billion year history of the universe were compressed into a single calendar year, the Big Bang would occur on the first second of January 1st. This galaxy, this monstrous beacon, would appear before dawn on January 3rd. For comparison, our own sun would ignite only in late August. Humanity would not crawl out of the muck until the last 10 seconds of New Year's Eve. On this cosmic scale, 280 million years is the blink of an eye. It is the universe's first breath. In the universe's first breath, as cosmic space was just beginning to form, galaxy JADES GS-Z14-0 appeared to researchers not as a fragile, barely nascent cluster, but as a structure of astonishing brightness. It was not a dim collection of the first, timidly flickering lights. What the Webb telescope revealed was a formation of shocking intensity. It was a dazzling cosmic beacon, piercing the primordial fog with its radiance, a light from an era previously considered a period of cosmic silence. The luminosity of this ancient object was so powerful, so unexpectedly bright, that it defied the established chronology of cosmic creation. Previously, it was believed that billions of years were required for galaxies capable of shining with such energy to form. Yet here, in a cosmic era when we expected to find only a few scattered clusters, stood a fully formed stellar megalopolis, ablaze with the light of hundreds of millions of suns. Such a thing seemed simply impossible. A torrent of infrared information, having traveled over 13.5 billion years, poured back to Earth. On the screens of the Space Telescope Science Institute, this light was converted into images and spectra, and the numerical data confirmed the astonishing visual picture. This was no optical illusion. Dr. Stefano Carniani of the Scuola Normale Superiore in Pisa, one of the key authors of this discovery, could only express a sense of pure scientific shock. It's remarkable, he stated, that the universe is able to create such a galaxy in only 300 million years. The word remarkable in the context of cosmology is a significant understatement. It is a polite term that often means impossible. This was a direct and jarring contradiction to the majestic, gradual model of cosmic evolution that the scientific community had cherished for decades. How could something like this exist? Stunned by this discovery, the scientific community frantically began searching for an explanation. The standard model of galaxy formation was clearly insufficient. It predicted a slow, methodical construction process. Imagine building a city the size of New York, brick by brick, over centuries. That's the process the standard model described. However, what Webb found was the equivalent of such a city appearing, fully built and lit, in just the first 5 minutes. A completely new, more turbulent mechanism was required. The first candidate for this role was a phenomenon known as starburst formation. This theory rejects the idea of a slow, steady rate of star formation. Instead, it proposes that the earliest galaxies were not calm cradles, but rather cosmic firestorms. It paints a picture of a period of incredibly efficient, unimaginably violent star formation. Think of it not as a steady burn, but as a series of colossal explosions. A huge, dense cloud of primordial hydrogen gas, hundreds of thousands of light-years across, begins to collapse under its own powerful gravity. However, instead of forming stars at a leisurely pace, some trigger, perhaps a collision with another gas cloud or a shockwave from a supernova, initiates a catastrophic chain reaction. Imagine a monstrous stormfront of collapsing gas, a wave of gravitational chaos. Within this front, thousands, then millions of stars ignite almost simultaneously. These are not like our Sun. These are the first generation, the so-called population 3 stars, born from pure hydrogen and helium. These are true titans, hundreds of times more massive than our star, and they burn with a dazzling blue-white fury. Their lifespans are brutally short, just a few million years before they detonate in supernovae of unimaginable power. But in this starburst model, death is only the beginning. The crushing force of these explosions doesn't disperse the gas. Instead, it compresses it. The shockwaves become midwives for a new, even more furious generation of stars. Each supernova becomes a trigger for 1,000 others. It's a self-sustaining cycle of violent birth and death. The galaxy becomes a cosmic engine of creation, converting its fuel, raw gas, into stars with a terrifying efficiency our own Milky Way can only dream of. This is a process of monstrous speed, a factory running at 1,000,000 times its design capacity. Theoretically, this could generate the colossal luminosity observed in Jade's GS Z14-0. It was a plausible, albeit terrifying, picture of the early cosmos, but it represented only one piece of a darker puzzle. Amidst the theoretical deliberations, another, far more unsettling hypothesis emerged. What if the dazzling radiance emanating from these early galaxies was not solely due to the light of stars? What if, at the very heart of these nascent cosmic formations, something significantly more ancient and incomparably more voracious lay hidden? This bold theory posited that the early universe might have been teeming with rapidly accreting supermassive black holes. Until this point, scientists had leaned towards the idea that black holes evolved slowly. It was assumed they originated as stellar mass objects, the remnants of colossal stars, and gradually built up their mass over billions of years, devouring gas and occasional stars, steadily growing in size like a patient predator awaiting its prey. However, this new, then seemingly heretical, idea proposed an entirely different scenario. It spoke of direct collapse black holes. According to this concept, in the unique, high-density conditions of the early universe, some giant gas clouds did not fragment into individual stars. They completely bypassed this star-forming stage. Instead, a cloud, whose mass could reach 100,000 times that of the Sun, could collapse directly in a single, swift gravitational event, forming a monstrous seed black hole. They didn't arise from the death of massive stars. Their birth was a result of pure cosmic potential. They were born already large and immensely hungry. Imagine one of these ancient monsters, situated at the center of a young galaxy. It would be an insatiable engine of accretion. Gas, dust, and newly born stars would be relentlessly drawn into its gravitational embrace, forming a swirling vortex of doomed matter known as an accretion disk. As this material spiraled closer to the event horizon, the point of no return, its velocity would increase to nearly the speed of light. Friction and magnetic shearing within this disk would reach such extreme values that the matter would heat to millions of degrees, emitting light whose intensity surpassed the luminosity of all the billions of stars in the galaxy combined. This phenomenon is known as a quasar, or quasi-stellar object. It is not a star, but a feeding black hole that through its luminosity outshines its entire host galaxy. A single dazzling point of light, acting as a cosmic searchlight, visible across the observable universe. This became a compelling explanation for the incredible brightness of objects like Jade's GS Z14-0. The galaxy might not have been as massive as its light suggested. It might simply have harbored a monstrous, actively feeding black hole at its core. a cosmic imposter whose furious hunger created the illusion of impossible stellar mass. The light we observed was not the gentle glow of billions of stars, but the death scream of tearing matter. It was a beautiful yet simultaneously terrifying solution. However, even these extreme explanations, these cosmic firestorms and ravenous monsters, began to unravel when confronted with the sheer volume of data collected by the James Webb Space Telescope. They might have been able to account for one or two anomalies, a single starburst galaxy here, a single quasar there. These could be dismissed as cosmic outliers, fascinating but ultimately rare exceptions to the rule. But what the James Webb Space Telescope found was not a few exceptions. It found an entire population. It was a whole ecosystem of the impossible. The numbers were relentless. As astronomers sifted through the treasure trove of deep survey data, chilling statistics began to emerge. In the first few 100 million years of the universe's existence, there weren't just a few more massive galaxies than predicted. There were roughly twice as many. This wasn't a rounding error. This wasn't a statistical fluke. This was a fundamental, crushing divergence from existing models. The result was so robust that it forced scientists to re-examine the most basic assumptions about the cosmos's development. Imagine it this way. You are a biologist studying a newly discovered island that you know for a fact rose from the ocean exactly 1 year ago. According to all known principles of biology and ecology, you would expect to find only the most primitive life. Lichens, mosses, perhaps a few hardy grasses. But instead, you land ashore and discover a towering ancient redwood forest, with trees thousands of years old, their roots deeply embedded in soil that, by all accounts, shouldn't exist. You might be able to concoct a wild theory for one such impossible tree. But what do you do when you find an entire forest of such trees? This was a genuine crisis looming over all of cosmological science. The existing hypotheses, such as the starburst model and the concept of hungry black holes, represented an attempt to explain a phenomenon that could be compared to a single, incredible redwood tree. However, these theories proved utterly insufficient when faced with an entire cosmic forest demanding explanation. The universe, it turned out, was not simply forming stars at an accelerated rate in a few unique regions. It was not just giving birth to a few insatiable black holes. The processes underway were far more fundamental and widespread. The cosmos was literally assembling entire colossal systems, stars, gas, dust, and an invisible halo of dark matter, at a speed that seemed cosmically forbidden, violating all known laws. The very factory of creation was being erected in the blink of an eye. The foundation of galactic structure was forming with a rapidity that modern physics could not comprehend. The problem was no longer solely about the luminosity of objects. It lay in the assembly process itself. The universe wasn't just turning on the lights ahead of schedule. It was building an entire city, from the sewage system to the magnificent skyscrapers, at a pace that defied all known blueprints of creation. This anomaly was deeper, more systemic, and far more unsettling than a few bright lights flaring in the vast dark. And then, the situation escalated even further. A final, insurmountable contradiction emerged. A discovery so profound, so paradoxical, that it threatened to stretch the very fabric of cosmic understanding to its breaking point. Scientists had not yet recovered from the shock of impossible creation, from the emergence of colossal galaxies arising at a speed that defied all existing models. They were struggling to make sense of a universe evolving in fast forward, a genesis characterized by dazzling and turbulent efficiency. But what the James Webb Space Telescope demonstrated fundamentally shifted perceptions. Previously, our understanding of galactic evolution rested on a foundation of slow, patient processes. A galaxy was conceived as a cosmic ecosystem, a vast reservoir of cold hydrogen and helium gas. Over hundreds of millions, even billions of years, this gas was supposed to gradually cool, condense under the gentle but relentless pull of gravity, collapsing into vast, churning nebulae where new stars would then ignite. This process was considered self-regulating, a slow burn. The very stars it created were thought to have a repellent effect, their radiation and stellar winds heating the surrounding gas, preventing it from collapsing too quickly. It was a cosmic dance of creation and feedback, a cycle that should have sustained a galaxy for eons. A galaxy, it was assumed, only died or became quenched when this reservoir of cold gas was exhausted or violently ejected. This was thought to be the fate reserved for ancient, mature galaxies in a crowded, middle-aged universe. However, the galaxy RUBISUDSQGZ7 was observed as it was just 700 million years after the Big Bang. This is a cosmic nanosecond. The universe had barely cooled from its tumultuous creation, and yet here stood this colossal entity, having already forged an astonishing 15 billion times the mass of our Sun in stars. And then, inexplicably, it went silent. Its stellar forges cooled. Its nurseries were empty. Imagine a team of architects given a barren desert plot. By all known principles of engineering and logistics, it should take them a century to erect a single skyscraper. But instead, in just one day, they build an entire megalopolis, a city of 1,000 towers, each gleaming and impossibly complex. The world is stunned by this feat of impossible creation. But when observers return the next morning, they find the city completely abandoned. The lights are off, the streets are empty. A thick layer of dust is already settling in the silent halls of these brand new towers. The construction itself was a miracle that defied the laws of physics. But its abandonment, its premature death, that is an even deeper and more unsettling mystery. This is how RUBISUDSQGZ7 appeared, a colossal structure built in a cosmic blink, only to become a ghost city moments later. How could this happen? What cosmic force could be so monstrously powerful as to halt the star-forming engine of an entire galaxy in such a short span of time? The theories themselves are terrifying. Perhaps a supermassive black hole of truly disgusting size lurked at its core, which, after a short and furious period of feasting, turned on at full power. It would have unleashed jets of plasma and radiation, two beams of pure energy moving at nearly the speed of light, so furious and blindingly powerful that they would act as a cosmic hurricane, completely blowing every molecule of cold star-forming gas out of the galaxy, sterilizing it and ejecting its potential for life into the desolate intergalactic void. Or, perhaps, the galaxy's own star formation proved fatal. A period of creation so furious and explosive that it triggered a catastrophic chain reaction of supernovae. Billions of stars detonating in a cosmic cascade of explosions. A wave of crushing detonations that swept through the galaxy, heating its gas cloud to millions of degrees Celsius and stripping it of its ability to ever again form stars. Not only was the birth incredibly fast, but the death proved just as swift. The fact that we are seeing such quiescent galaxies so early in the universe's development, stated Tobias Lusser of the Kavli Institute for Cosmology, poses a pretty serious challenge to our models. This was a restrained academic statement, concealing a truly devastating truth. Our models were not just facing difficulties, they were failing. The discovery of one cosmic ghost was already a frightening anomaly, but the universe had more shocks in store for us. And then the situation worsened. Another group of astronomers, leveraging the unprecedented capabilities of the James Webb Space Telescope, embarked on a different project. Their goal was not to hunt for specific anomalies. They aimed to conduct a kind of census, to count the very first sources of light in another region of the cosmic dawn, within the first 500 million years after the Big Bang. They expected to find only a few faint, tentative flickers, the first pioneer stars, solitary embers in a vast and all-consuming darkness. Instead, as the data came in, disbelief gave way to outright shock. The number was wrong. The brightness was wrong. The very population of the early universe was not what was expected. Scientists identified 300 mysterious sources of light, whose sheer number and cumulative brightness completely defy every idea we have about galaxy formation. This should not have been possible. The standard model of cosmology is built upon the cosmic microwave background, the faint afterglow of the Big Bang. Tiny temperature fluctuations in this ancient light served as the seeds for all future structures. Gravity, acting on these minute variations over vast timescales, was supposed to slowly and patiently assemble matter. The first stars, known as population 3 stars, were theoretically monstrous. Yes, hundreds of times more massive than our Sun, but they were also supposed to be exceptionally rare. They were solitary beacons in an endless ocean of night. What this new survey found was not a few beacons. It was the equivalent of finding hundreds of brightly lit, continent-sized cities blazing on the surface of that dark ocean. This unexpected population both electrified and terrified the scientific community. It raises the most fundamental questions about how anything was born at all. Imagine mapping a previously uncharted desert, expecting to find at most a few nomadic campfires scattered across 1,000 miles of sand. But as your satellite imagery sharpens, it reveals not a few lights, but a sprawling network of 300 industrial blast furnaces, all operating at full capacity, their light visible even from orbit. The existence of these furnaces wouldn't just shatter your understanding of the desert's resources. It would shatter your understanding of history, technology, and civilization itself. You would be forced to ask, where did the fuel come from? Who built these? And how did they secretly erect such a colossal industrial complex in a place we believe to be barren? These 300 points of light pose the same terrifying cosmic questions. What are they? The explanations push our physics to its limits. Could they be galaxies fueled by a generation of stars so extreme, so alien, that they defy our neat classifications? Stars that burn with a dazzling, forbidden light for 1 million years before directly collapsing into black holes, seeding the universe with gravitational monsters? Or the far more unsettling thought, could these be direct collapse black holes? Primordial singularities, born not from stars at all, but forged in the insane pressures of the Big Bang itself. Now they are devouring pure, raw hydrogen gas with a terrifying efficiency our models never predicted. This could mean that the universe itself was born already populated by unimaginable monsters. And these bright flashes of light are nothing more than their ravenous, infantile screams. Each possible interpretation morphs into a chilling cosmic horror story, where each subsequent answer proves more unsettling than the original question. Currently, the scientific community is gripped in a feverish race, striving to confirm the existence of these objects, meticulously analyze their luminosity, and decipher their true nature. If even a small fraction of these 300 sources are confirmed to be what they appear to be, it could completely invalidate decades of painstaking work. It is capable of calling into question all our established theories about how the first stars and galaxies emerged billions of years ago. It directly indicates that the early universe was not at all a quiet, dark space of slow creation. On the contrary, it was a turbulent, crowded, dazzlingly bright realm, filled with objects we utterly do not understand, and driven by physical laws we are yet to discover. We naively believed we were constructing a simple, linear story of cosmic development, a story of life. Instead, we discovered a graveyard of impossible ghosts and inert. However, the universe has, with all clarity, proven us catastrophically wrong. The relentless stream of data from the James Webb Space Telescope hasn't just challenged our established theories. It has instigated a veritable, turbulent rebellion against them. Each new image, like a postcard from the very edge of time, only deepened this anomaly. The evidence was utterly irrefutable. Captured in cold, hard photons that had traveled over 13 billion years to reach Webb's golden mirror. Colossal, incredibly mature galaxies blazed in an era where, by all accounts, they should have had no place. The scientific community, once confident in its grand cosmic narrative, found itself adrift in a sea of devastating contradictions. The foundations of cosmology were not just cracking. They were trembling on the verge of complete collapse. We are now faced with a terrifying choice. There is no easy way forward, no elegant tweak to our equations that can explain this cosmic paradox. Instead, we stand at a crossroads, looking down three distinct corridors of thought. Each promises a potential answer, but each leads to its own unique and deeply unsettling form of cosmic horror. Each path demands that we sacrifice one of our most cherished beliefs about the nature of reality. To unravel the mystery of the impossible galaxies, we must confront the possibility that everything we thought we knew about the universe is wrong. The first corridor leads to the complete destruction of our greatest intellectual achievement, the Standard Model of cosmology. For decades, the lambda cold dark matter model, or lambda CDM, has been more than just a theory. It has been our map of existence. It was the story of cosmic genesis, written in the language of mathematics and confirmed by a stunning array of evidence. It painted a picture of majestic hierarchical growth, a universe unfolding with predictable gravitational grace. We thought we had the blueprint. We thought we had the very story of creation. Imagine this model as a colossal, incredibly complex cathedral, built over a century by the brightest minds in human history. Each pillar was a fundamental principle, each arch a mathematical proof. The cosmic microwave background, that faint residual heat of the Big Bang, mapped by instruments like the Planck satellite, was its cornerstone. The terrifying implication is not just that our model has a flaw. The horror is that the entire cathedral may be built on a foundation of sand. If the model is fundamentally wrong about how the first and largest structures in the universe formed, then what else is it wrong about? It would mean unlearning everything. It would mean that our confident calculations of the universe's age, the nature of dark energy, the very history of cosmic evolution, might be nothing more than a beautiful, intricate, and ultimately false illusion. It is the scientific equivalent of a historian discovering that the Roman Empire never existed. It is a devastating void of knowledge. To embrace this path is to admit that for the better part of a century, we have been mapping a phantom cosmos. We would have to tear down our cathedral, stone by stone, and stand naked in the cosmic dark with no map, no story, and the chilling realization that we are fundamentally lost. The second path, or as it can be characterized, the second corridor, appears in some respects even more unsettling and even terrifying. It does not require us to completely dismantle the entire existing cosmological model, but rather suggests the necessity of expelling a certain phantom that, as it turns out, resides within it. This alternative path of scientific thought hypothesizes that the root of the problem lies not in the holistic theory of cosmic evolution, but in its most enigmatic and yet most prevalent component, the so-called dark matter. For half a century now, dark matter has served as the invisible glue, ensuring the strength and coherence of our understanding of the universe's structure and development. We posited its existence not because we could observe it directly, but solely because, without its presence, the entire cosmological construct would inevitably fall apart. Galaxies, as is known, rotate with such astonishing speed that the gravitational pull of their visible stars and gas clouds is utterly insufficient to hold them together as a single structure. By all calculations, they should simply tear apart into individual fragments, ejecting their stars into the bottomless intergalactic void. It is here that dark matter offered itself as the only possible answer to this paradox. A vast, invisible halo of mass, like a cosmic shepherd, provided the necessary additional gravitational attraction, allowing these stellar cities to maintain their integrity. We envisioned it as silent, colossal scaffolding, emerging in the dark periods after the Big Bang. It was the invisible architecture upon which all visible matter would eventually condense. Ordinary, or baryonic matter, the stuff that stars, planets, and of course people are made of, was supposed to be gradually drawn into the deep gravitational wells formed by these dark scaffolds, slowly sinking into these invisible forms to create the galaxies we observe today. This was supposed to be a slow, patient process. However, the incredibly early and simultaneously incredibly massive galaxies discovered by the Webb Space Telescope flatly contradict this slowness. They assembled with astonishing, almost instantaneous speed. The invisible scaffolds, composed of cold dark matter, are simply physically incapable of concentrating their gravitational influence quickly enough to build such monstrous structures in such a short period. This is comparable to finding a fully formed pearl the size of a fist and concluding that it formed in just 1 second. The process itself seems broken, and then the situation only got worse. The failure of the existing theory forced scientists to turn once again to a kind of forbidden text, to a marginal idea that had remained on the periphery of astrophysics for decades. It is called MOND, which stands for Modified Newtonian Dynamics. First proposed in the 1980s by physicist Mordechai Milgram, MOND offers a disturbingly simple yet profoundly unsettling alternative. What if dark matter doesn't exist at all? What if the ghost in the machine was never there? What if the entity we have been hunting for 50 years is nothing more than a complete fabrication, a phantom invented to explain a phenomenon whose true cause is far stranger and more unexpected? MOND suggests that the responsibility lies not with some invisible substance, but with the fundamental force of gravity itself. The theory asserts that on the colossal scales of galaxies and in regions where gravitational acceleration becomes incredibly weak, the laws of gravity, first formulated by Newton and later refined by Einstein, simply change. They begin to behave in a completely different way. This is truly a terrifying assumption. It means that the force that holds our world together, the most familiar and constant force in our daily lives, is not an immutable constant at all. This is a cosmic horror of an entirely different kind. It means that within the universe's rule book itself, there are hidden clauses and exceptions that we are only just beginning to realize and notice. This is tantamount to discovering that the laws of chemistry manifest differently at the bottom of the ocean, or that the speed of light is not an absolute constant, but a variable quantity. To accept the concept of MOND is to agree that we inhabit a universe with a changeable, alien physics. The search for dark matter has been one of the largest and most expensive undertakings in the history of science, involving the creation of vast underground detectors, meticulously shielded from cosmic rays, waiting in absolute silence for the moment a single phantom particle collides with an atomic nucleus. The horror that MOND carries is that all this colossal effort may have been nothing more than a ghost hunt from the very beginning. We persistently searched for a missing ingredient, while we should have questioned the recipe itself. This path would force us to rewrite the most fundamental physics we have today. It would require admitting that the universe operates on a far more capricious and less uniform logic than we ever dared to imagine. It would replace a comfortable, albeit invisible, entity with a terrifying uncertainty about the fundamental laws of nature themselves. Now, finally, we arrive at the third corridor, which is perhaps the most existentially unsettling of all possible paths. It suggests that our cosmological model may be correct, our understanding of gravity and dark matter may also be correct, but we are catastrophically wrong about something far more fundamental: the very nature of the early universe. We have always operated under the foundational principle that the laws of physics remain constant throughout time and space. The forces governing a star today are assumed to be the same ones that guided primordial gas clouds 13 billion years ago. We imagined the infant universe as a simpler place, a cooling, expanding soup of hydrogen and helium, dark and relatively calm until the first stars ignited. We were convinced that the cosmic dawn was a gentle sunrise. However, the data from the James Webb Space Telescope paints a picture not of a gentle sunrise, but rather of a monstrous, blinding inferno. The sheer efficiency of galaxy formation in this era represents a terrifying anomaly. To build these colossal structures so quickly requires a level of cosmic construction that defies all human imagination. It would necessitate hyper-efficient star formation, converting gas into stars at rates hundreds of times faster than anything we observe in the universe today. It would also require the seeds of supermassive black holes to be sown almost instantaneously, perhaps through the direct collapse of monstrous clouds of primordial gas, creating gravitational anchors of impossible mass that our modern theories struggle to allow. The horror of this possibility lies in the notion that the early universe was not merely a younger version of our own. It was a fundamentally alien realm, an environment operating under different conditions, perhaps even with subtly differing physical constants that allowed for such a rate of creation and such a scale of violence that now seems impossible. Imagine our universe as a calm, tranquil lake. We have studied its currents and depths and believe we understand the rules that govern them. But Webb's discoveries are like finding the fossilized remains of a colossal, monstrous leviathan at the bottom of the lake. A creature so enormous and powerful that it could never have lived in these calm waters. The only possible conclusion is that the lake itself was once a raging, tumultuous primordial ocean, with different pressures, different temperatures, and a different chemistry that allowed such monsters to exist. This idea is the greatest cosmic horror. It implies that we live in the quiet, peaceful aftertaste of a truly monstrous and unknowable genesis. The universe's youth was a time of turbulent, hyper-efficient creation, a period of cosmic fury whose true nature is forever lost to us. We can see its ancient echoes in the form of these impossible galaxies, but we can never truly visit that alien epoch.
We are like archaeologists who have discovered a futuristic city built by an ancient civilization, a technological paradox that our understanding of their tools cannot explain. The only answer is that they had access to a science, to a power, that has now vanished from the world. This would mean that the universe is not a static stage on which cosmic history unfolds, but a changing, evolving entity with a past that is profoundly, terrifyingly different from its present. This makes us not just small observers in a vast cosmos, but latecomers to a reality whose most exciting and turbulent chapter has already concluded. A chapter written in a language of physics that we may never be able to decipher. So, we are left with these three crushing possibilities. First, that our map of the universe is a fiction. Second, that the fundamental laws of nature are not what we think they are. Or third, that we live in the quiet ashes of a monstrous alien creation. There is no easy answer. There is no comfortable choice. Each path forward demands a sacrifice, the destruction of some pillar of our understanding. The James Webb Space Telescope was built to show us our origins. Instead, it has shown us the terrifying depths of our own ignorance. It has given us a glimpse of a cosmos more ancient, more turbulent, and more mysterious than we ever could have imagined. The relentless pursuit of fundamental truth about creation continues, yet the era of unambiguous answers has irrevocably ended, leaving humanity alone with the silent contemplation of the vast cosmic abyss. We persistently strove to comprehend the earliest moments of existence, nurturing the hope of confirming our theoretical ideas, of catching the first, barely perceptible echoes of the universe's formation. To this end, the most powerful instrument ever created by human genius was aimed at the most distant, deepest, and darkest region of cosmic space that could be found. We expected to witness a slow, delicate dawn, a cosmic genesis where timid embers of matter would gradually, over endless eons, coalesce into the grand structures we observe today. Instead, what appeared before us was a deafening cosmic roar. We discovered a dazzling, turbulent chaos of creation in an era that, by our calculations, should have been filled with silence. The James Webb Space Telescope didn't just reveal a panorama of distant galaxies to us. It exposed the terrifying breadth of our ignorance. It held a mirror to our most cherished theories, revealing a monstrously distorted reflection. Our universe, it turns out, is far grander, significantly more mysterious, and infinitely more unsettling than any existing models could predict. If even one of the potential possibilities suggested by this exciting new data proves true, then our entire perception of reality will inevitably be threatened with destruction. Consider the first of these possibilities, that our most fundamental model of the cosmos, the lambda cold dark matter paradigm, is simply wrong.
For decades, this model served as our universal map of all existence. It was not just a theory, but the intellectual architecture upon which all modern cosmology rested. It was a colossal cathedral of thought, erected brick by painstaking brick. Its foundation was laid by observations from the Hubble Space Telescope, the faint, ancient glow of the cosmic microwave background meticulously mapped by the Planck satellite, and the subtle warping of space-time caused by invisible matter. The model told a majestic, elegant story of hierarchical formation, where tiny gravitational seeds of dark matter slowly and patiently gathered gas and dust over billions of years, forming the first star clusters, then dwarf galaxies, and then colossal spirals like our Milky Way. We were confident we understood the rules. We thought we understood the timeline. However, the Webb data presents a cosmic heresy. These massive, fully formed galaxies, blazing with the light of 1 trillion suns, just 300 million years after the Big Bang, are not just anomalies. They are an assertion that the map does not match the territory. They suggest that the elegant story of slow growth is nothing more than fiction. Abandoning the lambda CDM paradigm is not like upgrading software. It is akin to discovering that a continent you have mapped for a century does not in fact exist. It means admitting that the invisible scaffolding of dark matter that we believed held the universe together either functions in a completely different, incredibly fast way, or the entire concept is a ghost, a phantom we invented to explain gravity that we don't truly understand. This induces intellectual vertigo, a crushing realization that we may have been lost in the cosmic dark all this time. Or perhaps the problem lies even deeper, woven into the very fabric of existence. This is the second, more forbidden possibility, that gravity itself is not what we perceive it to be. The standard model requires the existence of dark matter. This invisible, intangible substance, making up 85% of all matter, is necessary precisely because there isn't enough gravity from what we see. It's not enough to hold galaxies together as they spin. It's not enough to bend light the way we observe it bending around galaxy clusters. Dark matter was the answer. A colossal, invisible presence whose gravitational embrace dictated the structure of the cosmos. But if it cannot explain these impossible early, impossibly massive galaxies, then we are forced to confront a terrifying alternative. This is an idea that has lurked in the shadows of physics for decades, a theory called modified Newtonian dynamics, or MOND. This theory proposes something far more radical. It suggests that dark matter does not exist. It suggests that the ghost was never there. Instead, it posits that Newton's and Einstein's laws of gravity, the bedrock of physics, are incomplete. That on the colossal scales of galaxies, gravity behaves differently. It becomes stronger, more powerful than our equations predict. Such an approach would certainly allow galactic systems to form at an unprecedented speed, eliminating the need for invisible dark matter. However, the potential consequences of such an assumption are truly staggering. It would mean that the fundamental forces governing nature are not constant values. Such a discovery would be tantamount to realizing that the speed of light changes as soon as you leave the confines of our solar system. We would find ourselves in a universe where the very rules of creation can transform, in a cosmos possessing a hidden, deeper set of laws whose existence we had previously not even suspected. The Webb telescope, by revealing these ancient, seemingly impossible structures, may have inadvertently presented us with the first real confirmation of this so-called forbidden physics. And now, the pressing question arises: what other fundamental laws have we mistakenly taken for universal and immutable truths? Then arises the third and perhaps the most cosmically terrifying hypothesis. Perhaps our current models are correct. Perhaps our understanding of gravitational interaction is indeed robust and accurate. But the early universe itself was a fundamentally different and infinitely more turbulent space than we ever dared to imagine. We are accustomed to envisioning the cosmic dawn as a relatively calm and gentle event. The first stars, we believed, should have been like solitary beacons, flickering in a vast and silent ocean of hydrogen gas. However, the data obtained from the Webb telescope paints an entirely different picture. Not a quiet ocean, but a raging cosmic maelstrom, an era of such extreme fury and efficiency that it defies all our existing physical conceptions. What if the infancy of the universe was populated by monstrous seeds, primordial black holes that were not born from the collapse of massive stars, but were forged in the first femtoseconds of the Big Bang itself? Each could have possessed the mass of 1,000 suns, acting as hyper-efficient gravitational anchors, sucking in matter with unimaginable ferocity, and initiating star formation processes on scales we can barely adequately model. Imagine a jet of plasma, blindingly bright, stretching for millions of light years, shooting out from a black hole in a galaxy that, by our understanding, should not yet exist. This is the level of cosmic violence we are talking about. Or perhaps the very constants of nature, such as the strength of the electromagnetic interaction or the gravitational constant, were different in that primordial cosmic furnace. A universe operating by a temporary, more brutal and merciless set of rules. This represents the greatest cosmic horror. The realization that we are not living in the same universe, but only in its current calm, moderate, and relatively peaceful epoch. It suggests that the cosmos has a hidden past, a turbulent youth whose rules were utterly alien to ours, capable of building colossal cities of stars in a time it takes our modern universe to form just one star cluster. This means that the universe is not just evolving, it is now a fundamentally different entity than it was in its youth. An ancient, constantly shape-shifting entity whose true nature is far more monstrous than our relatively gentle and simplified equations can describe. We thought we were close to understanding the true number of galaxies and the mechanisms of their emergence, but we were wrong, as always. Friends, thank you for watching. See you in the next video.